is the Silver Bullet Podcast with Gary McGraw. I'm your stunt double Gary for this session, Marcus Random. This podcast series is co-sponsored by Cigital and IEEE Security and Privacy magazine, where a portion of this interview will appear in print. For more, see www.computer.org/security or www.cigital.com/silverbullet. Today we're celebrating the 120th episode of Silver Bullet. That is exactly 1 decade of shows delivered on a monthly basis, 120 in a row, by producing a video in the Shenandoah Valley of Virginia where there's Black Hawk helicopters and weird flying reptiles. This is the 120th in a series of interviews with security gurus, and I'm pleased to have Silver Bullet's usual host with me today. Hi, Gary.
Hi, Marcus. Thanks for doing this.
Gary McGraw is the CTO of Cigital Inc., a software security consulting firm with headquarters in the Washington, D.C. area and 13 offices throughout the world. He's globally recognized authority on security and software and the author of 8 best-selling books on this topic. Dr. McGraw has also written over 100 peer-reviewed scientific publications and authors a periodic security column for Search Security. Besides serving as a strategic counselor for top businesses and IT executives, Gary's on the advisory boards of Max Financial, Intrepid, and Raven White. His dual PhD is in cognitive science and computer science from Indiana University, where he serves on the Dean's Advisory Council for the School of Informatics. Gary lives on the Shenandoah River with his wife Amy and his son Eli. His son Jack is a student at NYU. So you're one of the founders of the field of software security. How did you get into that?
You know, I was a programming languages weenie, besides being a cognitive science guy when I was in grad school. And so when Java came out, I was excited that there was going to be this programming language for the web, and, you know, got interested in the Java thing. It turned out to be much more like C++ than it was like a functional programming language like Scheme. And they were making all these claims about security, so we started breaking Java.
So you actually got excited by Java?
I got excited by breaking Java and wishing that it were better and wondering why those guys who built it made some of the decisions they made from a programming language's perspective when they built it.
So, I mean, did you believe the marketing hype that Java was a secure programming language? I mean, it was designed for elevator control systems, if I recall.
Yeah.
And then Sun Microsystems needed a web programming language, and they went, Java.
Yeah,
right?
It was called Oak in the early days. It was actually for set-top box cable systems.
Oh, I thought it was elevators.
No, it's all the same. And it was very closely based on P code from the 70s.
Yeah, programming languages are just programming languages. I mean, it's not like...
Yeah, so when it came out and they were saying, everything you build in Java is secure, it made us wonder what the heck they were talking about.
Right.
So we broke that a lot. I did a lot of work with Ed Felton from Princeton and his guys who were in grad school at the time. And after doing that work, it made me wonder why really good people screwed this all up when it came to software security. Like, if Bill Joy and Guy Steele can't get it right, what chance do mere mortals have?
It seems like the software industry, the way it's structured right now, is vastly more rewarding for people who are part of the problem rather than people who are part of the solution.
Isn't that a great irony?
Yeah, you know, so if you actually try to produce good software, you're going to be later in the release cycle, and the other guys are going to have 5 million customers before you're able to release that.
Yeah, there's that, and there's also the idea of being incented to put bugs in that you later take out. Like that one Dilbert. Remember when Wally was actually coding one day?
I just coded myself a new minivan.
Exactly, that one.
If Netscape had waited 3 releases to release the browser, they would have never been what they were. And as soon as we saw the Netscape IPO, I mean, where were you when Netscape went public?
I was actually still at Indiana when Netscape went public, and Netscape really didn't have, you know, Java in it in the beginning.
No, it wasn't a Java problem, but I mean, yeah. Kent Landfield and I were in the data center at Sterling Software the day the IPO happened, and we watched that ticker go through the roof, and it was the beginning of the 20-year beta test.
It knew the world was going to change.
Well,
now we have DevOps. We can make that cycle even tighter.
Yes, agile, right? I mean, as opposed to, you know, awkward. I kind of like awkward.
Agile is when you run away from your code that you just wrote as quickly as possible.
Right. So you've been on advisory boards for many companies. I've been on some of those as well. We kind of imagine it's, I don't know what people out there imagine it's like, but, you know, why don't you tell us a little bit about what being on an advisory board is?
Well, I guess
do you do?
Part of it is you're supposed to be a third set of eyes and kind of a person from Mars perspective to the company that you're giving advice to. And usually they'll put on a formal presentation, maybe about a new design or a new product idea or some sort of strategic move that they're going to make as a company. And the advisory board weighs in on that, helps to, get the flaws out of the design, talks to the engineering team directly, sometimes even takes a look at code, which we did in the very early days at Fortify. And, just generally provides outside counsel that is highly trustworthy.
Well, I think it's really interesting, when you're in the sausage factory and you're actually packing that sausage and someone comes from the outside and goes, did you think about doing this? You go, no, and that happens. We've all had those moments. But
it really happens when you're coding, right? So
absolutely,
you got this bug and you can't figure out the bug, and your friends call you for dinner because you're supposed to meet them for pizza, and they're like, where the heck are you? And then they finally come by your office and you're still working on this bug and it's driving you crazy. And the guy who comes in your office just says, oh, why'd you do that? And you go, that was the bug, that was it.
I remember when Andrew Lambeth and I were at V1, we spent an entire day trying to figure out why this one time conversion routine that he'd written and I reviewed and we looked at, it kept coming up with the wrong time. And of course, finally somebody said, well, did you take into account daylight savings time?
Yeah.
It should have been suspicious that it was exactly 1 hour off, You don't get that. Okay, so the Internet of Half-Baked Things is upon us. The other day I found this little wonderful item on Amazon.
Bluetooth 7000 dental professional toothbrush.
Talks Bluetooth to the base. And so whoa, Bluetooth isn't a problem, it's a local network. Well, how does the base get the data to the cloud? Right, so that the base of this toothbrush has got an IP address, and it's DHCPing something on your network, and it's going to some website and, personal information about how often you brush your teeth. But more likely your YouTube password is also going to be out there on that site.
Yep.
The thing is, people look at this and they go, well, there's no way that a toothbrush can actually hurt people.
Right.
So we don't have to worry about securing a toothbrush.
But they don't realize that it's taking some resource that is a finite quantity. And that's the key thing to think about while you're designing these things. And
it also means that if I'm outside of if I'm out on the internet and I can get access to your toothbrush records, I can tell when you're on vacation because you're not at home brushing your teeth.
You're actually in St. Croix brushing your teeth.
And I know it's time to break into your house and steal your toothbrush.
Of course, yeah.
Yeah. So how do you see this playing out? Are you going to be doing application whitelisting on your toothbrush? What if somebody gets a buffer overrunning your toothbrush? Or more to the point, if you're running a website and you find yourself under DDoS attack from 10,000 toothbrushes?
Software updates for everything. I think there's some possibility that because these devices are so small, we might be able to write better code because it's going to be smaller, tighter code, but that might be truly insane.
I don't think that's going to happen because it's going to be running Debian inside that somebody just said, well, here's an operating system.
Yeah, that's what happened to a lot of these embedded systems, including some car chips. As you know, the difference between a Ford 350 and a Ford 150 is just a bunch of EEPROM settings.
Right.
And so you might get a chip that's super cheap because there are bajillions of 8080 chips sitting around, for example, in a warehouse, and it's cheaper to put that into your dishwasher than it is to store it in a warehouse. So you end up having way too much computing capacity in your toothbrush, in your dishwasher, and everywhere else.
And the other big problem with this is that when you're dealing with a physical device that gets shipped through Amazon or whatever, you kind of have to get the software pretty much right the first time because you can't destock it and reship it when you've shipped 1 million light bulbs. It's not the same thing as...
Yeah. Well, even if it were the same thing doesn't work too well, say, in the mobile space. So if you think about Sony, for example, or Sony Mobile, who has to, have all these devices going way back to 5 years ago and support them all, that kernel and all the Linux code that's associated with the Android isn't being updated to keep things up to normal. And as a consumer company, those guys are sort of on the spot to make sure that that phone, even if it's 5, still works.
And here's the great part. That if they're shipping that using some version of a Linux or BSD or whatever kernel, it's got a kind of a half-baked version of IPv6 in it. which is enabled.
Right.
And all it needs is the correct packet sent, and that thing's going to go turn into a brick on you.
Isn't that nice?
I know. Well, I mean, so what are some of the most screwed up things, without naming any names, of the Internet of half-baked things that you've seen?
Well, you know, the most screwed up things, the things that worry me the most, I'm going to turn this one on you,
Okay.
are when the code really matters. Like control code for a vehicle, for an airplane, nuclear power plant control code. You can't screw that up. And it's like you can't, oops, I made a mistake, let me just DevOpsy that later. Because you create a 30,000 year problem if you screw up the code. So we've learned a lot of lessons from high assurance land, some of which we have been borrowing over the years into nonsense software land where we exist, you know, banks and everything else, consumer devices. And now it's trickling down to even sillier things like toothbrushes. But we can still borrow these good ideas from high assurance software and apply some of them while we're building these things.
So what do you think about Charles Perrow's normal accident theory? I mean, does normal accident theory apply when you start talking about a toothbrush? I mean, do we have a situation where you could have your toothbrushes exhaust your DHCP address and cause a reactor failure someplace else? I mean, do you see, is that our future?
It might be, because everything is ridiculously interconnected.
Correct.
You know, so if you're dumping noise from all of your toothbrushes onto the net, and a really important message needs to get by, but the toothbrush traffic is too heavy, what you gonna do?
Yeah, all the toothbrushes are updating themselves at exactly the wrong time, I mean, you can get, you know, I think Perrow has got a point, which is, you know, by the way, don't ever read that book while you're landing in an airplane.
I know. Well, look, here's kind of a funny thing. When you're in computer science school, on the first day of class, you know, you don't get the bejesus scared out of you. But if you're in mechanical engineering class, you go and you see that bridge shake itself to death. And they go, this could be your bridge, and you're 20 and you're going, oh my God, I don't want to make a bridge that falls into the ocean.
Right.
You know, in
that could be your legacy.
Exactly. In computer science school, it's kind of like, oh, let's write hello world. You can build anything you want.
But you know, we do kind of get that. Eric Allman used to come up to me at Usenix and go, why do you hate me? What did I ever do to you? And I said, yeah, you didn't do anything to me. You just gave us sendmail and syslog.
Sendmail, yeah.
I mean, either sendmail or syslog would have been enough of a legacy in computer security.
My Usenix story like that is Larry Wall. It's like,
yeah.
You know, I was sitting on a panel with him one time and he said, Perl is fantastic because there's 6 ways to do everything. And I was right after him and I said, Perl really sucks from a security perspective because there's 6 ways to do everything and you only thought of blocking 4 of them.
Okay, so obviously this is going to get a lot worse before it gets better. At least I think it's going to get a lot worse.
I'm optimistic about the whole thing, you know that.
Are you?
Yeah.
Yeah, I mean, you know, years ago I was saying the only thing that's going to get the world community to take this problem seriously was a software Chernobyl.
Right.
Right. And I'm afraid that, you know, I don't want to be Cassandra, but it seems like eventually it's going to be inevitable that there's going to be some disaster.
There have been some, you know, the Ariane 5 rocket, the Therac 26 that burned a bunch of people to death with radiation. So we do know that life-critical systems have to be done better. And I actually think that we're making progress in even building consumer-grade commercial systems and doing a better job with that over the last 20 years. So it feels to me like the trend is in the right direction, not the wrong direction. Although you might argue, well, we're growing so fast that it'll never catch up.
I'm not sure I'm concerned about the growth factor as much as it's that, you know, the governments are looking at uncorking this new genie as, well, now we can screw you up by causing you economic damage, har har.
Yeah.
You know, by making your new reactor no longer function, it's going to cost you millions of dollars.
Yeah.
And
or slow down your nuclear weapons program by making your centrifuges fail to work properly.
Exactly, which of course is a violation of the Geneva Conventions to do, because you're not supposed to mess with nuclear powers.
It turns out war doesn't follow rules all the time, Marcus.
Actually, it turns out war never follows rules. You know, and that's where, you know, I always like to introduce the concept of a weapon of privilege in cyber war. You know, a weapon of privilege is one that I can use against you, but if you even dream about using it against me, you better wake up and apologize.
Yeah,
right?
Yeah, and well, there are a lot of those because we have a nuclear deterrent in the United States as well. So you got to factor that in. You know, something could go kinetic, but I think one of the important things to realize about, say, cyber warfare and this whole thing is that the best way to avoid it is to engineer ourselves stuff that's really much better and way more expensive and basically outspend our adversaries building stuff properly. And that's the deterrent. The deterrent is our engineering's great and yours isn't so great. Go.
Yeah, I agree. If you could actually deny your enemy the ability to have a seat at the battlefield, you make it so much more expensive for them, which is basically what's happened with the nuclear weapons around the world. Is they've made it so expensive to play in that space that just the cost ought to deter pretty much anybody rational. Although one of the popular things for people to say is, it's irrational to want to have nuclear weapons, but actually it's profoundly rational to want to have nuclear weapons.
Yeah, well, in a mutually assured destruction situation, that's true.
Right.
But I think cyber war is complicated economically because the cost of building, say, a disruptive thing that was destructive of some information-based, important piece of life, like, I don't know, the water system or something like that, or power control systems, is cheap. Right. I mean, developing something to screw that up might cost $10 million, not $10 billion. And the number of countries out there that have even, a $6 billion budget for defense is pretty big.
But, if you're an individual who is motivated, you can manipulate a government's response to something simply by saying, I'm going to make it so expensive for you to collect my taxes that it's no longer worth collecting my taxes.
Right, right. I remember talking with you about that in Amsterdam about 5 years ago it was.
Yeah, and you thought
we were walking around in the rain, remember that?
Yeah, and you said that was some really morally repellent stuff I was working on, and you're one of the reasons why I never published that, because I look at the anonymoids and generally I'm kind of sympathetic to what they're doing. But, so on the doctrines of cyber insurgency stuff, I made you this tinfoil hat.
Thanks, I think.
You can wear.
Let me put it on. I'll wear it in Bubba mode.
Wear it in Bubba mode. So I mean, this is goofy, but the surveillance state, as it's currently growing, where we've got the government that is basically asserting its electronic domain over much of what we're doing. But, if you actually wanted to launch attacks against the government on a 5 to 10 year life cycle, instead of this basic smash and grab stuff that we're seeing, how do you prevent somebody from embedding themselves in the development organization that's producing software that's running the federal government?
So the Tea Party insurgency is actually a bunch of dev guys.
It would be the new. It would be the new version. I mean, imagine if you. I mean, you know this. Like if you and I wanted to put together a project to take the IRS offline, we'd get 3 network administrators, 2 systems administrators, and 5 programmers, and they'd never know what hit them. It would just be a 5-year-long effort. And I think the big issue on cyber insurgency is that governments don't really think on an effective 10-year time cycle.
I think you're right, but I think that some organizations do, and I know for a fact that some financial services organizations are thinking about that sort of thing.
People who run lotteries.
And redoing everything, not the people who run lotteries, financial services, the people who run big banks and move around bits that count as money.
What's the end game here? If you were responsible for a government agency that was particularly critical, how do you prevent somebody who thinks on a 10-year assault cycle from embedding programmers in the development process?
I mean, you don't even need to do that. Are you kidding? The database is sitting there in the clear at the OPM. So all you got to do is just go grab it. I think that you're worried about a possible world that's worth thinking about, but it's also way more effort than it takes to take a government down today.
Yeah, I definitely agree with that. But it's like the way I like to think about strategy.
I'm wondering why I have my tinfoil hat on, though.
Well, it's because I was talking about the surveillance state.
Oh. And you were talking in the clear, and I was good, but I didn't actually say anything.
Probably didn't hear it. See, the tinfoil hat's working. But I mean, here's a problem. I mean, suppose I'm someone, right? We hear consistently that the NSA and the surveillance state have been inside the algorithm development and have mooted SSL from the beginning. And some of us knew this was going to happen, right? What if somebody was inside the NSA's code development or inside the CIA's code development and mooted the NSA or CIA's code development. And in that situation, I think a 5-year, 10-year program cycle for that attack is more realistic.
And you know that sort of thing is happening. I mean, you have to build something from first principles, including the compilers and the chip fab stuff and everything.
But yet they run Windows.
At some parts of them run Windows. So the question is whether there's really true compartmentalization in some areas. And one would hope the answer is yes, but we don't really know. But you know what, Marcus, if you think about society and how we've sort of kludged our way along as a species, just barely surviving, we've been doing it for 30,000 years. So it's not like the end of the world has come because there's a new domain now. It's just the same crappy kludges that we've always had, you know, because it's evolutionary pressure on this one planet that we're talking about.
You know, I was at Source Boston, I think.
No,
yeah, you can take that off now. Yeah, let's get back to being a little bit more serious. But, you know, I don't know if you remember my evolutionary biologist friend, Robin, you know, and I took her to Source Boston, and one of the keynote speakers was talking about evolutionary models and security.
Yeah.
And in the question period, she stood up at the end and said, you know, I am an actual evolutionary biologist, and I've got to tell you, for evolutionary algorithms to work, you have to be willing to suffer billions of casualties.
Exactly. You need to have generations wiped out. And that's the way the genome moves, because we're talking about genomes moving.
And we're not prepared to suffer that in computing. I mean, what happens, well, you know, what happens when an entire operating systems tree dies, or, you know, as is what is happening to Java. I mean, that branch of programming, I think, is dead at this point. You'd be crazy to be putting any investment into writing more Java code.
There are an awful lot of people still writing enterprise Java code.
People writing Fortran, too.
To do things. Yeah, I don't think any old code ever dies. I think that's one of the really terrible things about programming is if you wrote it 20 years ago, it's still somewhere. And somebody's going to find it and run it. Yeah, and it has your name on it. Here's the best part. So all these vendors that are creating security mechanisms, you know, with millions of lines of new code, think that they're building more security to put in front of the broken stuff, but they're actually increasing the pile of the broken stuff and the attack surface at the same time. So, you know, if you realize that the cloud is somebody else's computer, right, and you realize that these security mechanisms are somebody else's code, it makes you think twice about the way we're doing some parts of computer security these days.
But I mean, it seems to me like the federal government is outsourcing running a lot of stuff to Beltway bandits that write the code.
Who don't know anything about software security. In fact, if you think about the vast middle market and these people that are system administrators for mom and pop shops or whatever, or just Cousin Joe who knows something about Winders, those people are probably better replaced by the engineers at Google or Amazon or Microsoft. So in some sense, that movement to the cloud can be a good thing from a security perspective, even while for some people who do know what they're doing, it can be a bad thing. It really depends on where you sit and, you know, how you want to operate your enterprise.
Well, it's a basic business problem. You decide whether to change your own oil in your car or whether to let somebody else do it for you.
Yeah.
And then the other question is, if you know how to change your own oil in your car, you've got a better chance of telling if the guy didn't do it right.
Yeah, that's a good point.
You know nothing about how oil changes work, and you drive away and there's oil splashing out the bottom of your oil pan. If you know nothing about it, you might go, huh.
Well, then you become an anti-vaxxer, you know, and you think that science is bad even though you like your electricity.
That's right.
Ah.
That's right. Okay, so you play violin, you mix drinks, you raise goats, you live on a farm where birds poop on your interviewers. But what else do you do? What are some other fun things that you do just to keep yourself busy?
Well, you know, the music thing is really important, but you mentioned that.
Yeah.
The party thing is important. What else do I do? Oh, I read a lot.
What are you reading right now?
I like to read fiction. I just started this book and I can't recall the name of it, but the book I read right before that is a new one by a woman from NYU who just graduated named Julia Pierpoint, and I think it's called 10,000 Pieces or 10,000 Things, something like that. Fantastic to see a young person writing with such insight about human existence. That's really cool. So it kind of refreshes my, I don't know, feeling about humanity not being a terrible, horrible disaster, when you read the thinking of some of these people that they put into their fiction. That makes me happy.
Are you an optimist or a pessimist?
I am a radical moderate neutralist.
So you're like one of those radical lefto-rightists?
A lefto-rightist, yeah, sort of. Yeah, I mean, I'm a liberal, but I own a bunch of guns, which you and I have shot many times.
Well, owning guns doesn't make you conservative.
No, I know, but that's what the gun people think, generally speaking.
Interesting.
Yeah.
Interesting. Well, this has been a Silver Bullet Security Podcast with Gary McGraw, hosted today by your stunt double, Gary McGraw. Silver Bullet is co-sponsored by Cigital and IEEE Security and Privacy magazine and syndicated by Inform IT. Show links, notes, and an online discussion can be found at the Silver Bullet webpage at www.cigital.com/silverbullet. This is Marcus Randall.